Hello everyone. So today we will solve Codeforces round 1042 Div 3 problem C. Make it equal. So here we are given two multisets S and T and their size is n. And we are also given a positive integer k. B may perform operation in the first multiset such that we may remove any element and we may in place of that we may put x specific or x in something like. So if x is an element from first multiset, so we will replace it with x plus k, or we may replace it with x minus k. And if it become negative, then in that case we will take mod of this value. So we may perform this operation any number of times. Now, if we will perform the operation on the first multiset, and if we are able to make both the multisets equal, in that case we will output yes, otherwise no. So if we are able to make them equal, make both the multisets equal, in that case we will output yes, otherwise no. So this is the problem statement, and if we talk about some test cases, then here n is 1 and k is 3, 1, 3, 1. So n is 1, k is equal to 3. This is the first case, test case, and the multiset contain the first multiset is 1 and the second multiset is 2. So we will perform operation like this. We will subtract k from this, then in that case it will become minus 2 and it become negative. Then we will take mod, it will become positive. So we will be able to make the both the multisets equal. In that case, the answer will be yes. Now, if we see another test case like test case 3, here n is 5, n is equal to 3, and k is 5, and we are given 6 to 9, 8 for 11, 6. So we are given 6 to 9, and the second multiset was 8 for 11. So we may perform operations like we may subtract k from this. If we subtract 9 minus 5, it will become 4. And for the first element, we may add k. In that case, we add k. Then we subtracted k. If we add k, it become 11. And in the for the second element, we may perform like we subtract k. If we subtract k, then it will become minus 3. We will take mod, it will become 3. Now we will add k, then it will become 8. So now we are getting 11, 8, 4, which is equal to 8, 4, 11. So now both the multisets become equal. Now we will output Yes, for this case. So this is the problem. Now, if we talk about the approach, so we are also given like a value of any 2 into 10 power 5 means the expected time complexity will be, since it is 2 into 10 power 5, so expected time complexity will be nearly n log n. Okay, so if we talk about the approach, then since we are given, uh, so for an element, we may perform operations like this. We may subtract something, we may add something on this, or we may subtract any number of times from this. Okay, these were the two operations we are given. So for first operation, we will try to reduce them in some small form. So for first x plus ik, we will try to reduce them in some small form like x mod k, and then we will add the value. Similarly, for the second case, x minus ik, we will try to reduce them in some in this form x mod k. Okay, and after that we may add up any number of times k. So here we need to understand these two things. Example, we may take n is equal to, we may take n is equal to 7 and k is equal to 5. So if we add 5, it will come 12. If we again add 5, it will become 17. If we subtract 5, it becomes 2. If we again subtract 5, it will become minus 3. We will take mod, it will become plus 3, and it will become 8. So if we focus on this, this was the number x mod k. And this was the number we were getting k minus x mod k. Now, all the numbers from this to this side, they will of the form x mod k plus ik, and all the numbers to this side will be of the form k minus x mod k. And we may add ik. So this is the approach we may follow. Now, after performing these operations, we will first of all put all the elements from the first multiset into the map data structure. And for the when we process the second multiset, in that case, if the if the element is present in the map data structure, like if it is present, means is a small form is present. In that case, we will reduce its frequency. And else, if its complement form may also be present, so we will also check that also. And if it is present, we will reduce its frequency. And if it is on the third case, if it is not present in that case, we will make the flag false, false or zero. In that case, we will not able to make both the multisets equal. So we will return. So this is the case for no. Yes, we will not able to make them equal. So we will. This is the approach. Now we will talk about the implementation. We will try to implement the code. So first of all, we will include the header files. Now writing the main function and sync with studio. This is for faster input output. This will untie sync from cout. This will avoid unnecessary flush. So now we'll process the test cases. We'll take the given input and key. Uh, for the first multiset, we may go from 1 to n. We store them in map data structures. So we will declare globally. We will clear the map for each test cases. Now we put the value in map data structure. We will put the value in smallest form. Now we will increase their frequency. Now we process the second array. Now, if its value is present, we will reduce them in the map data structure. We will also check for its complement value. At present, we will reduce value. Otherwise, in the third case, we may declare some flag which will come false if do not satisfy for some element. Okay. Now, if we successfully able to process all the element, in that case, it will be our true case, and we will make able to make the both arrays equal. Otherwise, it is not possible. If any one of the element is not able to process, in that case, it will become. So the overall time. So we may run the test cases also. Okay, we are getting some comparison error. Okay, so we are getting correct output. Okay, we may submit this code. Okay, it got accepted. If we talk about the time complexity, since we are traversing the whole arrays, so it will be n, and for map it will be log n. So the overall time complexity will be n log n, and this is the whole code. Thank you.